Baik, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And today we'll present about the stepper motor. And let me introduce our group. And the first member is Bagus Wirawan D, Elanda, Ghandur Athallah, Muchlisul Huda, and Zulfikar Iannur. Next. Stepper motor. A stepper motor is an electric motor whose main feature is that it self-rotates by performing steps. That is by moving by a fixed amount of degrees. This feature is obtained because of the internal structure of the motor and allows to know the exact angular position of the shaft by simply counting how many steps have been performed, with no need for a sensor. This feature also makes it fit for a wide range of applications. Next. This is how working principle of stepper motor. As all with electric motor, stepper motors have a stationary part is the stator and the moving part there is the rotor. On the stator, there are teeth on which coil are wired, while the rotor is either a permanent magnet or a variable resistance iron core. And figure below shows a drawing representing the section of the motor is shown, where the rotor is a variable reaction iron core. And the picture there are stator, rotor, and stator winding. Next.
The basic working principle of the stepper motor is by energizing one or more of the stator phase. A magnetic field is generated by the current flowing in the coil and the rotor alike with this field. By supply difference phase is sequence, the rotor can be rotated by a specific amount to reach the desired final position. And the beginning, coil A is energized and the rotor is aligned with the magnetic field it produces. When coil B is recognized, the rotor rotates clockwise by 60 degrees to align with the new magnetic field. The same happens when coil C is energized. In the picture, the color of the stator teeth indicate the direction of the magnetic fields generated by the stator winding. And this is 3D simulation variable resistance stepper motor. And next.
Stepper motor type and construction. For a stepper motor, there are basically their type of rotor. Permanent magnet rotor. The rotor is permanent magnet that aligns with the magnetic field generated by the stator circuit. This solution generates a good torque and also a detained torque. This means the motor will resist, even if not very strongly, to a change of position regardless of whether a coil is energized. Figure below show a representation of a scan of a permanent magnet stepper motor. Next. Variable reactance rotor. The rotor is made of an iron core and has a specific shape that allow it to align with the magnetic field. With this solution, it is easier to reach a higher speed and resolution. But the torque it develops is often lower and has no detent torque. Look at the picture below. Hybrid rotor. The skin of rotor has a specific construction and is a hybrid between permanent magnet and variable reluctance variation. The rotor has two caps with alternating teeth and is magnetized axially. This configuration allows the motor to have the advantage of both the permanent magnets and variable reluctance version, specifically high resolution, speed, and torque. Look at the picture below. Next.
Stator. The stator is the part of the motor responsible for creating the magnetic field with which the rotor is going to align. The main characteristic of the stator circuit include its number of phase and pole pairs, as well as the wire configuration. The number of phase is the number of independent coils, while the number of pole pairs indicates how many pairs of teeth are occupied by each phase. Two-phase stepper motor are the most commonly used, while three-phase is less common. In this left is the two-phase stepper motor, and in the right is the three-phase stepper motor. Stepper motor control. First, a transistor bridge is the device physically controlling the electric connection of the motor coils. Transistor can be seen as electrically controlled interrupters, which when closed allow the connection of a coil to the electrical supply and thus the flow of current in the coil. One transistor bridge is needed for each motor phase. Second, a pre-driver is a device that controls the activation of the transistor, providing the required voltage and current. It is in turn controlled by an MCU. Third, an MCU is a microcontroller unit, which is usually programmed by the motor use and generates specific signal for the pre-driver to obtain the desired motor behavior.
Stepper motors advantages and disadvantage. The advantage, due to their internal structure, stepper motors do not require a sensor to detect the motor position. Since the motor moves by performing steps, by simply counting these steps, you can obtain the motor positions at a given time. In addition, stepper motor control is pretty simple. The motor does need a driver, but does not need a complex calculation or tuning to work properly. In general, the control effort is lower compared to other motors. With micro stepping, you can reach high position accuracy up to approximately 0.007 degrees. The stepper motors offer good torque at low speeds, are great for holding positions, and also tend to have a long lifespan. Next. And the disadvantage, they can miss a step if the load torque is too high. This negatively impacts the control since there is no way to know the real positions of the motor. Using micro stepping makes stepper motors even more likely to experience this issue. These motors always drain maximum current even when still, which makes efficiency worse and can cause overheating. The stepper motors have low torque and become pretty noisy at high speed. And finally, the stepper motors have low power density and low torque to inertia ratio. Next, stepper motor uses and application. And there are three applications for the stepper motors. And the first is printers at the printhead, paper feed, and scan bar. And for the robots, there are arm robot and the end effectors. And for the ATM machines, bill is for bill movement and tray elevators. Like that's all from our group. Thank you for your attention. I'm sorry for the mistaken, and Assalamualaikum warahmatullahi wabarakatuh.